Hi viewers, this is Sri Ramulu. So before watching this video, please subscribe my channel. My channel is as.s space physics. So today's topic is Joule expansion. So what is Joule expansion? Joule expansion is an irreversible expansion of a gas into an initially evacuated thermally isolated chamber. See here, so it is initially evacuated means a chamber in which all the gases are removed. All the gases are removed. That is simply what evacuated. So initially, what we have to do, we evacuate it. And thermally isolated means the walls of this chamber are thermally insulated. Means no heat is allowed. Okay, heat is constant. Whatever heat present inside, it maintains the same heat. Okay, for long time. Joule expansion is also known as free expansion. So this is also called as free expansion. It provides a convenient example for calculating changes in thermodynamic quantities. So it provides convenient for calculating what we can calculate by using this dynamic quantities. So thermodynamic quantities are such as internal energy, free energy, enthalpy, and Gibbs function. Okay, including a resulting increase in entropy of the universe. So not only it provides convenient examples and also entropy of the universe. In this free expansion, the gas has to perform internal work. So in this expansion, gas what it has to do? Internal work. Against what? Against intermolecular forces of attraction. All right, so against intermolecular forces of attraction. Hence internal energy decreases, resulting in cooling effect for real gases. So for real gases, so real gases means the gas which cannot obey the gas laws. If they obey, that is a perfect gas or ideal gas. So here internal energy of real gas, what happens? Decreases. As there is no change in internal energy, du is equals to minus dw is equals to 0. How we got this one? So we got this one from the first law of thermodynamic. So that is what? dq is equals to du plus dw. Right? So from this, and here dq is 0. Why? Because see here in the initial, it is a thermally isolated chamber. So in isolated chamber, heat is constant. Okay, when constant quantity is differentiable, it becomes 0. So it is 0, right? So 0 is equals to what? It is 0 is equals to du plus dw. And if you bring this dw this side, it now it is positive. If you bring this side, it is negative. So du is equals to what? This one only. Du is equals to dw. And here work done is what? So there is no change in internal energy. So internal energy is what? Here constant, here also. So then its differentiation is 0. So that is where w is also dw also 0. A real gas will always shows cooling effect. In case of ideal gas, so ideal gas means perfect gas. In case of ideal gas, there is no change in temperature. So for ideal gas, no change in temperature, but for real gas, change in temperature will occur. That is neither cooling nor heating effect. So it cannot show neither cooling and nor heating, because there is no intermolecular forces in perfect gas. So in real gas, what? Intermolecular forces present, but in perfect gas, no intermolecular forces present. So this is what? It is a Joule expansion. Only it is a Joule expansion. And after Joule expansions, we have one more thing, that is the difference between adiabatic and Joule-Thomson expansion. Only difference we have to read here. and see what are those difference. See here difference. Distinction between adiabatic and Joule-Thomson expansion. Okay, so here distinction means difference between adiabatic and Joule-Thomson. What is adiabatic? Adiabatic is any process that occurs without heat entering or leaving system. So in adiabatic process, what? Heat cannot leave and cannot enter means heat energy is constant in adiabatic. In joules here, Joule-Thomson effect states that change in temperature occurs when gas expands through porous plug into a region of lower temperature. Here, what? Gas has to enter from high pressure region to low pressure region. Okay, here the gas will uh, enter. Then what happens? A small change in temperature will occur. So that is a lower temperature will present. In adiabatic process, entropy is always constant in adiabatic process. Yes, entropy is always constant. So if you have to know, please watch the TS diagram. So in TS diagram I explained clearly. Entropy is always constant in adiabatic process. Enthalpy of the gas always remains constant in Joule-Thomson effect. Here entropy constant, here enthalpy constant. Cooling is always produced in ideal gas during adiabatic expansion. So in this expansion, cooling always produced for ideal gas only. For ideal gas, no cooling nor heating, no cooling nor or heating effect is observed. Here we cannot observe any cooling and any heating effect. Cooling is due to the work done against external pressure. Here cooling is because of what? It is because of external work done. And here cooling or heating is due to the work done against molecular force of attraction or repulsion. Here see, because of molecular forces only. Okay, cooling or heating is because of what? Work done against molecular force of either attraction or repulsion. The general formula for adiabatic process is PV power gamma is always constant. So see, their product PV power gamma is always constant, but gamma is what? Cp by Cv. The general equation for Joule-Thomson effect is dou T by dou P at constant enthalpy is equals to 1 by Cp T into dou V by dou T at constant P minus V. So it is Joule-Thomson effect equation. Okay, please keep in mind. Next, adiabatic change involves in a fall or rise in temperature of the system. If gas expands under adiabatic condition, its temperature falls. Here, when the gas expansion takes place, then only cooling effect will occur. Okay, in adiabatic process. At a, see in Joule-Thomson expansion, at a temperature called temperature of inversion, means at inversion temperature there is no change, there is no temperature changes. Okay, so at inversion temperature what? No changes will occur. So that is why here ideal gas cooling, neither cooling nor heating, neither cooling nor heating effect will occur. So that at which temperature it neither cooling nor heating effect occur, that temperature is called inversion temperature. There is no temperature change. Okay, above this temperature of inversion, the gas is heated by expansion. Below it, it is cooled. Above it, heated, and below it, what? Cooled. So inversion temperature, above inversion temperature, heating effect, and below inversion temperature, cooling effect. But at inversion temperature, neither cooling nor heating. Work is done by the gas only here. Here work is done by the gas and on the gas. Both process will take place here. Okay. Adiabatic expansion is called isentropic expansion. Isentropic means entropy constant. Joule-Thomson expansion is isenthalpic expansion, means enthalpy is constant. Isenthalpic, isentropic, entropy constant, enthalpy constant. Next, adiabatic expansion is a reversible process. Okay, it is always reversible, and a Joule-Thomson effect is always irreversible process. In adiabatic expansion, a real gas is always shows cooling effect. right? So here real gas, not perfect gas, real gas always shows cooling effect. In Joule-Thomson effect, cooling or heating is produced depending upon whether the initial temperature of the real gas is below or above the temperature of inversion. Okay, if initial temperature is above the temperature, heating effect. Initial temperature is below one, cooling effect. Under similar condition, adiabatic process produces more cooling. Here, under similar conditions means all the conditions are same. Then what? Adiabatic produces what? More cooling. Under similar condition, Joule Kelvin expansion shows less cooling than that of adiabatic process. Here also shows cooling, but its cooling is comparing to this one very much less. Okay, so these are the main differences in both the adiabatic and a Joule-Thomson expansion. And above one is was what? This is Joule expansion only. Okay, okay friends, bye.